And again, this is what I was talking about, right? The marginal productivity of capital is decreasing, right? The gradient of the curve is decreasing. So as you stack your capital, less output occurs, or output occurs at a lower sort of step. And this makes sense, right? Because imagine, imagine having, 200 computers, but only one person. How do you operate? How do you sort of efficiently operate all the computers, right? That's really what it's getting at, It's not, it's unsustainable, right? So anyway, let's move on slightly. So the next thing we have to do is we have to set up our economy, okay? So this is a closed economy, right? This is a closed economy without a government. So you might recall that aggregate demand, which is equal to Y, okay? Same as our income, is equal to consumption plus investment plus government spending plus exports minus imports, okay? You might be used to this. However, what we're saying is the economy is small. It does not affect external. Yeah, it has, it does not affect external sort of economies. The other assumption is there is no government, therefore no G or P, right? There is no tax on your income. So 100% of income is retained. That's the key point. And then finally, the economy is closed, right? So there is no X or M. So that is how we transform. That is exactly how we transform from our aggregate demand to this identity right here. And again, and this is exactly what we've said here, right? Now, again, we convert it to per worker terms, okay? So we define lowercase c as the consumption per capita, and we define lowercase I as the investment per capita, all right? That's all we're doing, so nothing crazy. Now, if we move further down, we then consider one final thing, okay? Each person makes an income Y, right? Now, they save some of it, right? There's a saving rate. Now, we assume that this is exogenous. In other words, it is just assume we have no control over it. It is determined externally, right? In other words, think of it like the weather, okay? We don't have control over it, determined externally. So that is, yeah, that's our consumption. So that is the savings rate, which then comes into here. So this is the amount of income saved. So YS is essentially, in words, amount of income saved per capita, right? And then the remainder, right, which is going to be Y1 minus S, that is, of course, going to be, the amount of income that is consumed, used in consumption, let's say. The amount of income that's used in consumption, right? So that's our next one. Okay, so this can be used to close the economy at this point. So let's hop over to our next page. So again, this is saying the same thing, right? Our savings per worker is SY, and we know that our consumptions is going to be 1 minus SY. And we also recall, remember that we said that y is equal to fk, right? We said that y is equal to fk. Therefore, we know that our investment is equal to since y, right? Well, we can see it here, right? We know that y equals c plus I. So we know that I equals y minus c, which is equal to sy. So we know that sy is equal to I, right? In other words, the market for savings and investment clears. Okay. The market for savings and investment clears. That's a really key point here. But the point is, we also know that y is equal to f. So we can put our SFK in here. Okay. Fantastic. Sorry, just looking for the clear button. So the point is, we're going to just skip across these. We can now define, and this is the fundamental equation of the Solow model, we can define capital accumulation, okay? Capital is formed through investment. Okay, capital is formed through investment. However, capital depreciates at a rate K. And we know from our above mathematics we did a second ago that I is equal to SFK. We know that this is the function, right? This is the growth function.